Hello everyone, my name is Zach Barnes, and today we'll be going over continuity along with the three different forms of discontinuity and their graphs. So the first thing that we have to go over when we discuss continuity in calculus is, what is it? What is continuity? And what it is when we graph our function, there is a y value for every x value that we have in our graph. So this means that we can trace our entire function with our pencil without picking it up. There are no breaks and no jumps and no interruptions within our line. So with that being said, we can go over the different forms of discontinuity and when our function is discontinuous. So the first kind of discontinuity we have is known as removable discontinuity. So this is found when we graph our function, say like so. However, there's an open circle along with a closed circle seen here. And so we can determine removable discontinuity when the limit of x approaches a number, we'll call it a for now, from the left is equal to the limit of x approaches a from the right. However, when we find f of a, we find that this is equal to another value, something different. Okay? And this is how we find removable discontinuity, and it's called removable because we're able to, if we wanted to, we can get rid of this discontinuity by just placing this function over where this open circle is. Okay? So the second form of discontinuity is called the infinite discontinuity. And this is also referred to as a form of non-removable discontinuity. So we have infinite discontinuity. So in this form, when we graph our function, we have a vertical asymptote featured here by this dashed line. And this is when our function approaches our vertical asymptote. However, they don't touch. See how there's this kind of gap in between our two lines here at the vertical asymptote. And this is a break, and we can determine this kind of discontinuity when either one of our limits approaching a from the left or our limit approaching a from the right are equal to plus or minus infinity. Okay? And this is only referring to infinite discontinuity when we have a vertical asymptote. So it's critical for you to find that value before you really move forward. Now the third kind of discontinuity we're going to go over today is jump discontinuity. And this is another form of non-removable discontinuity. And this is found when we graph our function and there's a sort of break in between the graphs. So here we see open circle and a closed circle. However, as we move and we trace our function, we see that there's a gap in between here. And that's why we call it jump discontinuity, because our graphs are jumping from one y value to another. Okay? And we can determine this when the limit of x approaches a from the left does not equal the limit of x approaches a from the right, and both of these values do not equal f of a. Okay? And neither of these will ever equal plus or minus infinity. And this is really key to understand when you're trying to decipher between infinite and jump discontinuity. So, in review, we know that continuity is when you're able to trace your line without any breaks. Removable discontinuity is when we find this open circle with a closed circle here. Infinite discontinuity always uses our vertical asymptote. And then jump discontinuity is when we find this massive break in between our two functions. Okay? I hope you find this video very helpful, and good luck with your future endeavors in calculus.